Now I'm going to talk about prediction for the naive Bayes classifier, specifically for email spam classification. So continuing from before, so this is a distribution for one particular email, and where this theta we've already learned during the training phase. So theta is treated as a fixed constant. And so now we're interested in, well, we see a new email, which we can extract these features y1 up to yj for. And in particular, we observe these little y1 up to yj. And we want to know whether this new email is spam or not. All right, so we're interested in, well, what is the probability that C is spam given these features? Well, what is this equal to? We're just going to use Bayes' rule. And for Bayes' rule, well, it's going to be C equals spam times probability of y1 equals y1 up to yj equals little yj, given C equals spam, all divided by, well, it's going to be divided by the probability of y1 equals little y1 up to yj equals little yj. But we can use total probability to break that up between the two classes. So it's just going to be, well, we're going to have one term that's the same as the numerator, and then plus what happens when the class is instead ham, and then y1 equals little y1 up to yj equals little yj for when the class label is ham. And so, well, what is this thing equal to? Well, we just use this, right? So in particular, this probability that C is equal to spam, well, this guy is just S, and this guy is going to be product. So this will be product from j equals 1 to j. And since the class is spam, we're going to be using qj to the power of yj times 1 minus qj to the power of 1 minus yj. All right? And so what I've written here, S times this product, is going to be the same as this guy here. Whereas for this other guy, this is going to be equal to 1 minus S for the probability of ham times product from j equals 1 to the capital J of pj to the yj times 1 minus pj to the 1 minus yj. Alright, so this is the probability that for this new email that it's spam, given the extracted features. So something to note is that for detecting whether something's spam or ham, you can just look at whether C equals spam given y1 equals y1 to yj equals little yj, whether this is greater than or equal to probability. The equal to part is kind of not very interesting, but if it's greater than the probability that the label is ham given the features, you can imagine if this is bigger than this, then we could declare that the email is spam. And so that's the same thing as asking for this ratio to be bigger than or equal to 1. So if this ratio is bigger than or equal to 1, we declare that C is spam. So you'll notice that by what we've written up here, if we had done the same for ham instead of spam, we're just going to get out the blue guy to be in the numerator, and then the denominator will still be this red guy plus this blue guy. So this guy is called the odds ratio. So basically, we can just look at this ratio, which is going to be S times J going from 1 to J of Qj Yj, 1 minus Qj, 1 minus Yj, divide by 1 minus S, product from 1 to J of Pj to the Yj, and 1 minus Pj to the 1 minus Yj. Alright, so we're just looking at whether this thing is greater than or equal to 1. So I'm bringing this up simply because this is nice in terms of doing computation. So doing a lot of products of probabilities, you might run into numerical issues. So what you can instead do is look at whether the log of this thing is bigger than or equal to log of 1. Well, log of 1 is just 0. So by pushing the log in, you'll end up with a bunch of log probabilities, which are nicer to deal with. So all the products will become sums. And so this thing is numerically easier to handle, and you'll run into less numerical issues. And not surprisingly, this thing is called the log odds ratio.